Hi, and welcome to this video on KernelHaven, an experimentation workbench for analyzing software product lines. In this video, we will also go more into the details on the motivation, and we will also show some of the experiments you can already conduct with the components we have in place on our GitHub website. So let's start with some words on the motivation. What we typically do in software engineering in general is that we explore our hypothesis typically by using tools. So we try to analyze early assumptions. We might also evolve these tools for evaluating our final approaches in the end. Or we even have to re-implement the tools just to fit our early results and then go on to have a final approach in the end. This also means that tools are typically unique, so they are designed for specific experiments made for the early assumption or the final approaches, or even for a particular kind of analysis and hypothesis we had. Then we realize them with dedicated data extraction and analysis algorithms, and they always require some standard capabilities like caching, logging, parallelization that we have to implement from time to time or any time again that we develop a new tool. Further, we also need specific setup of these tools for our experiment. So every time we conduct a new experiment, we may tweak a little bit around our tools just to get them run like we want to have them. And this also facilitate or have an impact on the reproduction of results, because other researchers which may be interested, who may be interested in reproducing our results or even reuse our tools, need a precise documentation on how to use the tools, how to get the results out of them. This is where KernelHaven comes into play, the core features the tool provides. In general, KernelHaven is an open infrastructure for software product line analysis, so it's dedicated to this domain of analysis. It allows you to rapidly set up and vary experiments. This is because we have a reusing of existing components, because there are so many tools in place that do a really good job in what they're designed for, so we don't want to do that every time again re-implementing them. So we can wrap them as plugins for this open infrastructure and reuse them either to reproduce the results other researchers already provided with these tools, or to get new results from these components. Further, we have technical services in this infrastructure like parallelization, caching, and logging. Someone who wants to re-implement his tool as a component for the infrastructure, or a new tool or a new component for that infrastructure, doesn't have to care about this technical service. It's wrapped by the infrastructure, you can rely on that and reuse it. Further, we have a configuration-based definition of experiments, which allows you, like the second bullet says, rapid setup and variation of experiments without going into the details of the implementation again, neither for the components nor for the infrastructure. You simply tweak a little bit about the configuration options we provide, or you may provide for your component, and you have the definition of your experiment. This also supports the reproduction of experiments, because the only thing you need is the infrastructure and the components, and of course the input data, and the configuration, and then it's done. You can reproduce the experiments as provided, let's say by a research paper or somewhere else. All these features is what we think of makes up an experimentation workbench. But KernelHaven is just an instance for that for software product line analysis. So it's not that infrastructure, that experimentation workbench, but it's a specific instance for software product line analysis. This was the motivation, so let's come to the actual demonstration of the tool. We will start with a quick overview on KernelHaven and how it looks like, the architecture, how it works, and then we will see how to install and how the initial setup of that tool looks like when you download it from our GitHub website. Further, and which might be the most interesting part, we will show you 3 different experiments and show you how to vary and how to use KernelHaven to conduct experiments of any kind. So let's start with the KernelHaven overview, which addresses the features presented earlier, like open infrastructure and reuse of existing components. What we typically do in software product line analysis is to extract information from certain types of artifacts. Typically these are code files, build files, and variability model files. Each of them having information about the actual functionality of the product line it provides, but also variability information like which features exist, where they are implemented, how they are implemented, and how they can be combined, which is part of the variability model. Therefore, KernelHaven consists of 3 extraction pipelines, or pipelines in general, for code build and variability model files, which feed the analysis. Analyses may either call themselves, so that you can build upon the results an earlier analysis provides to further evaluate and come up with new results. For extracting the information we need, we have the concept of extractors. So for each pipeline, you can specify a particular extractor, or you can even leave them out, which means that you can arbitrarily combine the pipelines or use the pipeline. So you can even leave out the model pipeline, as we will see later on. Finally, to relate extraction and analysis, there are the internal data models. I will not spend so much time on that. It's just that you know that there are certain element trees for code files, that we have a mapping between those files and presence conditions. So when will they be built, which we extract from the build information, and the variables and constraints we find in the feature model or in the variability model in general. Most interestingly is the configuration file. This is what actually holds the information about how to set up the entire infrastructure, which extractors to use, which analyses to use. And this is read by the pipeline configurator to set up the infrastructure before it's actually executed. Currently, we provide a certain set of extraction capabilities. So there are well-known tools like Undertaker, TypeChef, Cabled Miner in the domain of software product line analysis, which extract certain information from code files, from build files, and variability model files. So you can use them out of the box even now, download them, and use them for your specific experiment or for reusing and reproducing certain results. The same is for analysis capabilities. There we have, for example, the undead code block analysis, configuration mismatches and feature effects, or even we can produce certain metrics on a product line or for a product line. There you can also use them as components or out of the box for KernelHaven right now. We have to say at that point that this is our re-implementation of existing work partially. The same holds for the extraction capabilities. They are not our tools, but we wrap them for reusing them as part of the infrastructure. So this was a quick overview on KernelHaven and the current state of capabilities it provides out of the box, just for you to rapidly start working with that infrastructure. Now we will go on and have a look at the actual tool, so the installation and setup, which also gives a glance at the open infrastructure, and we will have a first look at the configuration-based definition of experiments. So what you typically do when you want to start working with a new tool, you need to download it first. At that point, it is that you have to go to our GitHub website. On the first glance, it might be a little bit confusing because there are more than 20 repositories, but don't be confused. We also offer some bundles for downloading it. So the most interesting part is the KernelHaven main infrastructure repository, where you can navigate not only because it's the main infrastructure you need anyway, but also here you find bundled releases for downloading. Depending on the licensing model you may want to have, there might be some restrictions on the plugins that will be in that bundle. But in our demo here, we will use the full bundle, so also including GPL licensing tools. After downloading, it's simply extracting the archive to a location you want to have. In our case, we call that simply KernelHaven, and it's nothing more to do. This is actually the installation. So at the first glance on the the contents we have in KernelHaven, you see a lot of folders for caching, logging, and so on. These are predefined, as you will see later on. Most interestingly is the plugin folder, where we find all the plugins that we currently have, so for extraction, for analysis, and so on. On the top level, we find these configuration files, which end with a .properties extension. You can open them with a simple text editor, and you see here, for example, some general pipeline parameters like where to store certain information or where to find it. These are the predefined directories we have on the top level in the directory. You can also configure the logging, so where to log and what level you want to log, and a set of parameters which are dedicated to input information, analysis, and the extraction pipelines. But we will go on later in detail to discuss what the specific or how to use these particular parameters. Just to know what we want to do now, we want to do the first experiment, which is a dead code analysis with Undertaker, which addresses the features of reusing existing components. Because Undertaker was there before, we wrapped this tool as a plugin, extraction plugin for KernelHaven, and we will further go into the details of configuration-based definition of experiments. What will happen in that experiment? First of all, this is the rather empty architecture we showed earlier. We first have to define what extractors to use to perform the dead code analysis. So we want to use Undertaker for code extraction, the k-build miner for build extraction, and kconfig reader for variability model extraction. What happens then is that Undertaker and k-build miner will execute or will be executed, and they are designed to extract information from code and from build, in particular presence conditions. These presence conditions guard the execution of certain code or build instructions, so that they are conditionally executed depending on how the condition in the if defined or in the if equal statement are evaluated. This evaluation depends on the information we have in the variability model. So there are these options used for constraining the execution are defined and later on selected. So if a certain feature is selected, it will have an impact on the execution of certain rules, in this case the build rule. But there might be some mismatches between the variability model, the build, and the code. And this may lead to dead code blocks, which means that no matter how we configure our variability model, some part of the code will never be part of any product. And this is what we want to find with the analysis built on the extraction capabilities of Undertaker, k-build miner, and kconfig reader. So how does it look like in KernelHaven? We go further into the details of the configuration file, and first of all we want to have some output on our console, so we set this to true. The dead code analysis is already in place, so we don't have to define that. What we have to do is to specify the path, so where we find our software product line to analyze. In this case it's a short demonstration software product line, so we have to define the path to it. The code model parameters are already there, so Undertaker is defined, but we want to disable the caching feature because we don't want to redo the same experiment again. We also need to specify where to find or where to start looking for the C and header files, and we reduce the threads to 2 because the local machine doesn't offer more capabilities. The build model parameters, the k-build miner extractor is also specified as the fully qualified main class name. We disable the caching feature again for this extraction pipeline, and we also need to specify where to start looking for build files. The variability model parameters just have to be adjusted to disable the caching. It's still kconfig reader is in place, and we don't have to specify here the main folder because it does it automatically. We save this as our particular properties file for this first demonstration, the first experiment. So the next step is only to execute KernelHaven. That's all you have to do. Specifying what you want to do in the configuration file and executing it as a typical jar, and passing the particular properties file as the single input to the infrastructure. We see now a lot of information about the setup and also that our extractor started and it's finalized. So there are no errors, so it might be that we have some first results from this experiment. So we have a look into our output folder and see here we have an Excel file. In this case you can also change it to other file types, but we provide that for better readability. And when we open that file, we see, okay, we checked for dead code blocks, but when we have a look into the actual file, it's empty. This might be because our software product line does not have any dead code blocks, which might be fine because we did it well. But it might also be because just looking at these code blocks is not enough to find all defects. So as you remember, Undertaker also only extracts these blocks of information, but maybe we have to go more into the details of our code to get more information out of it. And this is where we start our second experiment. It's still the dead code analysis, but we will change now to TypeChef. Also, TypeChef is a well-known tool, and it was there before. We wrapped this tool as a plugin for the KernelHaven infrastructure. The main difference to Undertaker is that TypeChef does macro expansion. It provides a complete abstract syntax tree of the code information or the code files we pass in. So it has a lot more details about the code. This will show now in reuse of existing components, and it will also show how rapidly it is to set up and vary, for example, in particular, a certain experiment. What happens is that we will start with the previous definition of our configuration, and the only thing we need to do is we exclude Undertaker as a code extractor, and we include TypeChef. Nothing more to do, and then we run Undertaker again. In KernelHaven, this is simply changing some of the parameters in our configuration file. So first of all, we need to change the extractor by changing the fully qualified main class name of the extractor to use. You know, the plugins are already in place. We change the files we want to extract to only C files because of the macro expansion. TypeChef includes header files anyway. Then we want to have a full abstract syntax tree to get most of the information we can get out of our code files. And because this process is rather memory consuming, we have to restrict this, we need to specify more memory for that particular process, so for this particular extraction pipeline. We save this as our second properties file and execute KernelHaven the same way we did it before, but with a different properties file here. As you see now, there are some more information on the console, like some warnings, so just because of our artificial software product line we use. And you can see more output, which might hint to that we found more information. So have a look into our results folder, results file. We still checked for dead code blocks, and now we found some. And this is just because we changed from pure block-based extraction of code information to a full abstract syntax tree, just by changing some of the parameters in our configuration file. It's easy as that, and you can use that out of the box. But we can not only use dead code analysis, we can also perform feature effect analysis. And this will also show you not only another way of rapidly varying experiments, but also how we support reproduction of experiments, because we will also show you the archiving feature now. What happens to our infrastructure and the KernelHaven setup? We first of all will exclude the model pipeline. Why is it? Because the feature effect analysis is designed to reverse engineer variability constraints from code and build artifacts. This means that in the end we can build upon this information get from the feature effect analysis to get the information about feature constraints from code and build, and maybe then rebuild a variability model in the end. However, we don't need information from that variability model for that particular analysis. Further, we change the analysis itself, so the dead code analysis is gone, and we will include the feature effect analysis. The other extraction pipelines will stay as is, just because we don't need more information for that particular analysis now. So in KernelHaven, this is rather similar to what we did for the previous experiment. We first need to exclude the entire variability model pipeline, and this is simply deleting all properties which are related to that pipeline. The build and code pipeline stay the same, but we need to change our analysis, which is similar to changing an extractor we change the fully qualified main class name of the analysis. And as we said, we want to show how to support reproduction. So we change our archiving, we enable our archiving feature, and we need to say where to store the archive in the end. Also, we will want to have the complete source tree as part of that archive. So reproducing the results is even easier because we will have the complete software product line as part of our archive. So we save that as our third demonstration properties file. We execute KernelHaven with that property and start it, and see that now the output looks again a little bit different. And it also takes a little bit longer in the end because of archiving all the information we need for reproduction. A quick look at the output shows us that we performed a feature effect analysis, and also that we found some of these feature effects as part of analyzing code and build information. Most interestingly, now we found on our desktop the archive. And when we have a look in it, we see that everything we need for reproduction is in it. There is the main jar file for executing the infrastructure, the demo3 properties file, the logging information output we had so far, and of course the source tree, which includes our software product line we analyzed. This is how we support reproduction in KernelHaven. So finally, we are done with our experiments. Just some few words on the validation we did so far with that tool. Of course, the early steps were to apply KernelHaven to Linux. So because this is the most well-known open source software product line, it was easier to show and see how and if KernelHaven works as expected. But KernelHaven is also used in other domains like the Revamp2 project, which is an tier 3 project. Here it is used for extracting information from product lines and products. It is used for validation and verification, and it is also used for co-evolution. Further, we have certain publications which include information on how we applied KernelHaven in industry, so for reverse engineering of industrial product lines. This will be published in the end of 2018 at the Software Product Line Conference. So as a conclusion, we showed you KernelHaven core features, except the technical services like parallelization and so on, because these are rather hard to show at on this level. We also expect follow-ups like integration of additional extractor analysis plugins, so there's ongoing work to wrap more existing tools or to implement new tools or new components for further analysis. And the concepts we showed you here, so the concepts of experimentation workbench, may also be transferred to other domains. So this tool is particular for software product line analysis, but the core ideas can be transferred to other domains as well. But most interestingly for you, you can use that tool. You can download it, you can reuse or use the infrastructure and the components which are already in place to set up a certain experiment or to use it for your particular experiment by extending it. So let's have a try.